Okay, I just wanted to give everybody a little overview of Chapter 7. Somebody requested a video, not where I focus on, say, a particular problem, but I focus on the idea behind the big ideas behind Chapter 7. This is really 7.2. And the idea is to master the normal curve, right? Um, and really what you're doing, besides not spelling connecting, right, is trying to connect intervals of random variables, right, to probabilities through the normal curve. The assumption is that the random variable is normally distributed in this chapter, and you're connecting intervals of random variables. Say for example, this one right here, where the value of the variable is less than 3, right? What does that mean in terms of a probability? And of course, the connection graphically is that the probability is just the area under the curve. The whole curve has an area of 1. And so the area under that's less than 3, right? The area that corresponds to a random variable less than 3 is just this part of the curve. I just made up a number, 70% here. That's not a real example, but that shows you the connection. And you see I have in gold here that this is the most important. The area is kind of nice to help you visualize it, but the real thing is to understand how intervals of random variables connect to probabilities through the normal curve. Okay. And whenever you're doing problems, you have to know which normal curve you're dealing with, because there's so many different normal curves. But every normal curve is determined by the mean and the standard deviation. So if you know those two things, you know exactly which normal curve you're talking about. Of course, graphically, what that means, mean is always just the middle of the normal curve, right? It's the value for the random variable that if you go straight up, you're going to hit the top of the curve. And the standard deviation is just kind of the distance here from the middle to kind of the point where the inflection point here, where it starts to, you see how it's curving up like a parabola here, and then it's an upward parabola, and then it starts to be kind of a downward parabola here. So that's the standard deviation. Standard deviation, the best way, the most convenient way, helpful way to think of it is it determines how wide and flat your normal curve is. So if the standard deviation is really big, the bump is going to be low and the curve is going to be spread out really wide. If it's small, the bump is big and the curve, is really compact from side to side, horizontally speaking. Now, one thing that's important to remember, sometimes they don't give you what the mean and the standard deviation is, but they'll just tell you that you got the standard normal curve. It's understood that the standard normal curve has a mean of 0 and a standard deviation of 1. Okay, so just if you don't see the mean and the standard deviation, look for the word standard normal curve or z-score to know that the mean is 0 and the standard deviation is 1. Okay, so going from one way to another, so from interval to probability. Okay, so what's the probability that the random variable is less than -2? Well, there's lots of different ways, lots of different methods to get this. In the old days, we had to use tables to do it, which was extremely inconvenient. There's also, people use their TI-83 calculators that'll do it. There's other computer programs like Minitab, but the most convenient, definitely for me, because it's built into this, and that it also gives you a nice graphical display while you're doing it, is use StatCrunch. So let me just show you where that's located. Whoops. So here's StatCrunch, and if you go to Stat Calculators, normal curve, you can see kind of a normal curve here. And notice the mean is 0 and 1. It always kind of starts off with the standard normal curve, but you can change this. So let's say the mean was 3, and the standard deviation was a half. Okay. Now here's what we're always talking about: is this box right here is going to be the value for the random variable, and this is going to be the probability. So what did I say? We wanted to do the probability that x is less than -2. So what's the probability that x is less than -2? I put in the and I've got to also control the way the inequality is facing. So this is telling me the probability that x is less than -2. I hit compute. Really, all that means is it's a really small number because the mean is 3, right? And the standard deviation is 0.5. So -2 is all the way over here. Let me do something that will have a little bit more sizable probability. So let's say, what's the probability that x is less than 2? Okay, so here's 2, right? The random variables along the bottom, and the probabilities are right here. And we get that it's about 2% chance of a random variable being less than 2 if the mean, if it's normally distributed and the mean is 3 and the standard deviation is 0.5. We can also flip this around, the inequality around, and see what's the probability that we get a value for the random variable greater than 2. And that just shows me the complement, or the other side, right? And this is quite high. It's like 90, almost 98%. What's the probability that we're going to have less than 3.2? Or sorry, this is greater than 3.2. Less than 3.2, I have to rearrange the inequality sign. That's about, about 66% when we round? And you can see this red shading gives you the sense that, this is about 66% of the area under the curve. Okay. It's really the connection of the value for a random variable, and also the direction of the inequality that determines where the interval is, and then the probability. So, okay. So that's one way, right? I said originally that it connects the two, so we should be able to go both ways, going from intervals to probability, but also going from probability to intervals, and that's true. Okay. We can use StatCrunch to do it. We just have to fill in different boxes. So if I take this, if I take this normal curve that I've got going with a mean of 3 and a standard deviation of 0.5, and I want to know, right, what interval below what number would have a probability of having 60% of the curve, right? I find out if the random variable is 3.12, that will give me 60% of the curve on the low side. Okay. Well, let me do another one. Let's say, what's the probability? Sorry, we want say an 80% probability. I got to enter this as a decimal. What's the interval where we get 80% of the curve on the high side or on the right side? And that would be about 2.6. Okay. So the interval from 2.6 to infinity would give me about 80% of the curve on the high side. Okay. There's other things that you can do with the calculator. There's between, right? So if we wanted to know what's the middle 80% of the curve, we could do that. And that's between about 2.4 and 3.6. We could also find out what percent of the distribution is between, say, 2 and 3. Now this is going to give me a probability, right? Well, that's about 47%. This shading is about 47% of the curve. So I hope that helps a little bit, just makes sense. There's, of course, complications and special words like percentile and things like that you need to know, and we can go over those on the specific problem demos. But just connect with this, the most basic understanding. The main idea is that we're going to have intervals of random variables connected to probabilities through the normal curve, and we can use StatCrunch to do that. There are other ways besides StatCrunch, but StatCrunch is probably the easiest